a simulation that I think will help you to visualize this a little bit better. But with this simulation, you're actually going to simulate the percentage of food absorbed into the bloodstream down here versus what's staying inside the small intestine. And we're going to actually adjust the height of the villi all the way to their healthiest, which would be at a 10 right here, okay? So now I'm going to hit go, and I'm going to start to see the villi. So here they are. You can see the capillaries, these tiny blood vessels feeding into the main bloodstream and blood supply. And then you can see, so here's that inner space within the small intestine tunnel. And these little tiny dots are glucose molecules. Now, if we look over at this graph right here, you can see that there's a gray line and a red line and time on the x-axis, percentage on the y-axis. So what this is showing us is that over time, that if the villi is at its full height, that the amount of food that's in the small intestine is going down, but the amount of food that's going into the bloodstream is going up. And this is healthy. This is exactly what is supposed to be happening in order for glucose to get around the body and provide all of our cells with that quick burst of energy. But let me ask you something. What do you think would happen if the inner lining of the small intestine was flat? So in order to model this, I'm going to move the small intestine height down to 0. And I'm going to reset this, and let's see what happens now. So you can see there's no finger-like projections. And it looks like some of the glucose molecules are getting into the bloodstream, but they are not increasing nearly as quickly as they were before. You can see that, again, a little bit is leaving the small intestine, but not a lot. Not nearly as much as there was before. So here it was when it was at 10, right? Here it was when it was at 0.